Hello, everybody. Good morning, or good afternoon, and good evening.
Hello.
Hello, Michael. I think we can start the meeting.
Okay. Let's start. Can you see my screen?
Yep. Yes, we can.
Okay. Hello, everyone. I'm Wei He, and the host of today's meeting. This is the agenda. First, I will share the progress of Harbor version 2.0. Then Steven Zhou will introduce Harbor operator for us. After that, Pierre from OVH team will demo the operator. The last is the time for the free discussions. Okay, let me share the progress of Harbor version 2.0. Last week, all features of version 2.0 include OCI refactor, integration with Travis scanner, TRS for the interlock compliance, and others are completed. RC and GA will be in April.
Wait. Sorry for interrupting. Did you play your slides? I only see the first slide. It's my problem? Yeah.
Now, can you see my slides?
Yep.
Yeah.
Oh, okay. Today and yesterday, we did the first testing activity for version 2.0, and some issues were created. In the following weeks, we will focus on to fix those issues and add more E2E tests and clean up course. This is all the progress of Harbor version 2.0. Thank you. Next, welcome Steven Zhou to introduce the Harbor operator.
Okay, thank you, Wei. Please stop the share. Let me share my screen.
Okay.
Okay, can you guys see my slides?
Yes.
Okay, so before Pierre do their demo, I'd like to use several minutes to quickly share the overview of our Harbor operator. So here is a simple diagram to describe what we will deliver our Harbor operator. So far, we have a operator, we call it a Harbor operator. This operator is donated by Pierre, the OVH team, and this operator will focus on the manage the life cycle of only the Harbor service components. It will not cover any dependent service Harbor rely on, like the database, Redis, and the storage. So this is a pure operator for the pure Harbor. Okay, so I think that's not enough. So based on this operator, we will design and develop a Harbor cluster operator. This operator will, provide a Harbor cluster CR. This CR will be will cover the all-in-one solution. That means besides the Harbor service components, we also, manage the its dependent service like post-seeker Redis cluster and possibly some in-cluster storage will use the MEO to take that responsibility. So the Harbor cluster will be a all-in-one solution for deliver a high available and scalability Harbor service. Okay, for the post-taker Redis and MEL, that's will leverage some community operators. They are already there, so we'll leverage those operators to deliver our operators. So, and the last part, we also cover the backup operator. So in future, this is our last part. After we complete, release some Harbor cluster or Harbor operator, we are back to see if we can deliver the backup and recover scenario. Okay. So far, the Harbor corporate and the Harbor class operate are developed in parallel. They are, maintaining different code repository, and in future, not too long term, in future, we'll merge those two operators as one operator. That means we'll have a very flexible operator to cover. You can use only external dependent service, or you can deliver all in one Harbor. Okay. So that's the overview of the operator. So I think for this here is a diagram to show the relationship between the different operator. So far, based on current design, when you deliver all-in-one, use the Harbor cluster to deploy all-in-one Harbor service, there will be rely on maybe 5 different operators. They have different controller to manage the different CR. I think the top one is the Harbor cluster. This Harbor cluster CR will own the Harbor CR, and also own the post-seeker Redis and MEO CR. And for the Harbor CR, based on the current design, Harbor CR will rely on the Kubernetes built-in resource type like deployment, secret configure map, or service to construct the overall Harbor service. So, and in future, the Harbor operator that maintains the Harbor CR will do some improvements for each service. For each service component of Harbor, we'll define a new CR for that service component. So in future, Harbor CR will own different service component CRs that will make the reconcile process very high efficient and maybe more simple and more powerful. So that's
and also, Stephen, in some of the cases, we might use CRs built by other community members. For example, for Postgres or for Redis, there may be existing CRs, custom resources out there that manage their entire lifecycle, right?
Yeah, correct. Okay, so for the operator release plan, I think the Harbor operator will release the first release, that's the 0.5 before end of April. And for the 1.0, so far we still have any concrete plan. Once we finalize the plan, we will share with the community. Okay, and for the Harbor cluster operator, we have 3 community contributors. They have from Yunmanman, from NetEase, from QingCloud. These 3 guys will work on the Harbor class operator, of course, based on Harbor operator and other community database already operator to deliver the class operator. So far, this work is only in the design phase, not any code is introduced. So no any concrete release plan. Same with if once we have a concrete release plan, we'll share with the community. So that's overall view of the Arbor operator design and the roadmap. Okay, now back to Wei. I think maybe we can invite Pierre to do the more detailed introduction and the demo.
Okay, let's go. Let me share my screen. Hello, everybody. So,
Hello, Pierre.
Hey, Pierre, we can't see your
yeah,
screen.
yeah, okay. Sorry about that. I'm not on my.
Hello.
Hi.
I guess Pierre is gonna log in on our on his desktop as well.
Hey, Steven, can you share the slide about the operator? So can I get
Hello, can you hear me?
Yes.
Yes.
Yeah? Okay, good. Sorry about that. I'm not in the office. I'm in quarantine here, so not easy. Okay. My browser is preventing access to share my screen. Okay, why that?
So you have problem to share your screen?
Yeah, exactly. I can't allow Firefox to share my screen. It's a system D here due to quarantine, sorry.
Hey, Steven Zhao, do you have the slides that Pierre wanted to show? If you have the slides, then just share them and then Pierre can walk through them.
I sent slide in a Slack.
Slack.
But I wanted to show a few comments in my terminal, so trying hard here to share my screen again.
Give me 1 minute.
Hey, Pierre, you may want to download the Zoom client, either for your Mac, Linux, or Windows, instead of, I believe you may be logging through the web browser, which might be harder to share.
Yeah, but if I'm not wrong, it requires root to install the Zoom client.
Yeah, I can help you to share your slides. You just tell
Yeah,
me
thank
when
you,
to,
Steven.
slide.
Or we were sharing. Yes, Steven. So here, I'm here to present you the operator. I'm Pierre from OVH, which is a cloud provider. So in the few story behind this operator is why we needed an operator, and I will show you how we built it and how it works. So Steven, let's go. Thank you. As a cloud provider, we have needs. The first one is to manage hundreds of Arbor stacks. We see that you guys worked on the M chart to deploy Arbor, but on our side, it's not enough because we cannot manage hundreds of Arbors through M charts. It's a really pain in the ass. So we need to have management on demand, that means with API. And sadly, mchart is not an API. And the last but not least is to have a reaction over external or internal event. Imagine adding DNS imaging adding IPLB or whatever external stuff can trigger in our configuration, the operator can react and interact directly with the right component. Component, I mean Arbor Core or Notary or whatever. That are our needs. So yeah, thank you, Steven. Can you go to the next slide? So how it works? How does it work? We have a custom resource definition. Maybe all of you know what it is. In that custom resource definition, we have few specifications like public URL, database, and storage configuration. That's the minimal requirement for an Arbor to work. Then, with that resource, which is only a body in an API call, we have events that are triggered by the Kubernetes system. We can add an Arbor resource in the Kubernetes API. We can update it and delete it. What does the operator? So in the first case, add an Arbor is simply react to the event, receive the event, and construct the Kubernetes resources to deploy the stack. So construct internally in memory, I mean, and then apply to the Kubernetes API. So what does it mean? It means that we only use the public Arbor image. We use the Arbor core from Docker Hub and run it in the Kubernetes. So the operator is pretty simple, in fact. Then the other simple use case is to update the Arbor resource, which is simply change the Go object in memory and apply it to the Kubernetes. By the way, it also delete unwanted resources. Imagine a specification with Chat Museum, which are updated to delete the Chat Museum. The operator take care of this case and simply delete the pod where Chat Museum is running. The last case is to delete an Arbor resource. In that case, the operator simply does nothing because all is done by the Kubernetes garbage collection system. And all resources are owned by the Arbor resource. Steven, can you go to the next slide, please? So I wanted to show a few commands in my terminal, but like I said, I'm not at the office, so I was afraid about the live bug, and I set up a few screenshots here. To deploy the operator, it's simply one single pod. You can see it in red, the Arbor Core Operator Controller Manager XXX. This is the main and only pod which contains the operator. All other pods are dependencies. Like Steven said, the operator has many external requirements about databases, about certificate management, about Redis, about whatever. So here to install the operator, we need a cert manager and the application itself. Okay, please, Steven. So here we installed the operator, and now we install Arbor Requirements. So we have a management about certificate, and now we have management about databases and Redis. If I'm not wrong, no, we also have the router. Maybe you know the ingress controller. Ingress controller is here to route traffic to the right Arbor, depending on the request. we wrote a request thanks to the public domain. I'm in the TLDR. Not sure how to say that in English, but yeah, thanks to the domain. I will show you where we can find it and where we can change, update it. So here is the Arbor requirements, and then Steven, I will show you the last, but probably not least, the sample Arbor, which is deployed, and thanks to theming, it's easy to deploy the Arbor sample from the repository. So Arbor sample, no, yes, thank you. The Arbor sample is simply a custom resource. Steven, can you go back to the Arbor sample, please? Yeah. We have in the last line, Arbor go arbor.io. Arbor sample is a Arbor resource with a public URL. You can try it and go to the arbor. Oh no, I forgot arbor.registry.deparent.ovh. But yeah, it's so we have the public URL, and it owns all pod you can see over there. So this Arbor handles the chart museum, the CLAIRE, the core, and job service notary features, and all are managed by the operator you just saw. Okay. Oh, I wanted to to send a few comments, but okay. Thank you, Steven. So yeah, please keep it this slide. How to access to Arbor? I mean, that's nice. Please go back to the password slide. The previous one. Steven, can you go back to the previous slide? Thank you. So how to access to Arbor? I mean, we deployed an Arbor stack. Yes, that's nice. But how to serve this password to customer? How to expose that password? How to handle the permission and RBAC to access to this password? All this permission management are handled by the Kubernetes API, and this is exposed to a specific resource which is secret. So if a user can access to this secret in the right namespace, in the right Kubernetes cluster, it can display the password and go to the Arbor UI and connect thanks to the admin user. So this is simply automation about management of the Arbor and exposing features and all stuff. The link between this password and the Arbor resource is in the next slide. That Steven will press the right key, please. Thank you. I talked about specifications about the Arbor resource. So customers, clients, or people, or users, or whatever, will set up their own admin password secret, which is the same name that the previous secret I show you. So that means if they have I don't know, we are thanks to this link we handle many cases where people can generate password and others can only read only. So we have read-write access different for people. We have this. Okay, not sure how to explain that, but thanks to this kind of links between Arbor resource and secret resource, we handle many permission cases use cases. We have the same kind of architecture with database secret. So in the middle of the slide, we have core database secret and job service ready secret and notary database secret. We have database this secret pretty much everywhere because every component requires the database. But thanks to that kind of list, with a kind of link, we can manage pool of databases in secret resources and link to the Arbor resource. And that's pretty nice to automate all of the stuff. You can see in the end of this specification the public URL, which is sample registry.paperrun.obh. The simple demo that I wanted to show you is to update this public URL, and you will see this change live. But just please trust me, it works. And let's go ahead. About the title of this slide, we have Arbor specs, specification, and Arbor config. As you can see, we have no configuration about Arbor itself in this specification, except probably the public access, public URL. Yeah, we wanted to split that kind of job configuration. I mean, the real core, the real signification about the Arbor configuration and the technical infrastructure and architecture about that with databases, the access to this and whatever. So we have a difference between Arbor specification and Arbor configuration. Okay, Stephen, can you go to the next slide, please? So in this slide, we have two things. The first one is, at this moment, we have configuration in specification. It's an issue in the first development, but we can improve it. In the next to the red, the blue, the blue dash, we have vulnerability sources and worker count, which are probably configuration. This kind of information are in the Arbor configuration itself and should be in an external resource, which is configuration. But the way we will handle it, Stephen explained it earlier, is to have splitted specification with splitted resources. We will have the portal resource, the job service resource, etc. And that means we will have some kind of merge about configuration and specification, where in fact portal specification is like portal configuration and job service specification is job service configuration, because it will be simpler for everything. And so yeah, that is the release 0.5 is simply a few upgrades about the installation to be easier and documentation. And the release 1.0 is about splitting the resources. One other point, I would like to watch statuses. I mean, in this slide, I only show you the specification, but Kubernetes has also statuses in every resource. And I would like to, I don't know, set up the job service only if the Redis is really ready. And to know if it is ready, just it should be based on the Kubernetes status. So that's what I mean about statuses. So here we go. At the end. If you have any question, don't hesitate.
Thank you so much, Pierre. So I also wanted to mention that with a lot of the work that the OVH Cloud team did on Arbor, we're very fortunate for them to be huge contributors to our community and donate the operator to Arbor. So we've released a blog post announcing that, and very important now.
And we are happy to be part of that. So
yeah, absolutely. And then Jeremy and Pierre are also now maintainers of Arbor, and they will continue contributing to our community and enhancing the operator, like both Pierre and Steven Zhao mentioned earlier. And we welcome all their future contributions, and we look forward to seeing the operator be the method for lifecycle management of Arbor moving forward for everyone. Thank you all.
Oh, thank you, Pierre. Everyone has any questions?
Mm-hmm.
Hi, this is Daniel from Aqua. It was somehow explained, but just to make sure that I understood correctly. So far, I see you support Claire as a vulnerability scanner. I'm wondering how difficult or how easy it would be to extend the operator to include other pluggable scanners. Is it something that should be contributed by the vendors, or are you going to implement the CRDs for most popular scanners? If you could comment on that, that would be great.
Yeah, there is two answers on your question. We have at this moment, it's we have to copy paste many files about Claire and rename it to Trivy. That's not hard, but pretty painful. In the next release, the 1.0, you will have specific resource, and it will be easier for anyone to implement their own scanner and their own statuses. I don't know if a scanner is ready, okay, but is it up to date? Is it overloaded? I don't know. There is many statuses possible, and with the next release, it will be easier for everyone to handle.
Yeah, I'd like to say more words about Daniel's question. So, from my understanding, for our operator, we only cover the default scanner. So for other scanner, we will not cover it in operator. So that will mean after 2.0, we will cover both Claire and Trivy. But for other pluggable scanners, they need to to install with their way and configure through the Arbor dashboard, not operator. Operator will keep consistent with other installation approach we provided so far. So we only cover the default scanner.
Yeah, got it. Makes sense. Thank you
all. Other questions?
We have a question in chat.
Yeah.
Yeah, can we scale specific services? Yeah, not. We provide this replication count on every component, so you can deploy 2 registries and 2 Arbor core independently. But we do not handle every use case. For example, if you deploy 2 Arbor core you may have issue to share session, and with two registries you may have issue to share secrets, the HTTP secret, whatever, I don't remember. But yeah, you can scale it, but be, caution about the shared secrets between replicated components. You see what I mean? Welcome.
Oh, everyone has other questions to ask. How about supporting Prometheus metrics?
So we are huge fan about Prometheus metrics, and the operator itself already exposed a few metrics, but honestly, it's it's really poor. And we have metrics about other components, for example, registry exposed metrics. This metric is not handled by the Arbor operator, but it is natively handled by the Prometheus operator. Maybe you know that operator, but Prometheus has its own operator, and it handles the scrap of every slash metrics on every component.
All right, folks, we're out of time as well, so we should probably end this meeting. And if there's any additional questions or concerns, please post them on Slack on the Arbor channel or on the mailing list, and we can try to answer them.
Oh, okay, thank you, man. Thank you, everyone.
Thank you all. Have a great day or evening.
Thank you.
Thank you.
Thank you.
Thank you,
Thank you all.
Pierre. Bye.
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 Bye.